Question 3. Two towns A 65 degrees south, 35 degrees east, and B 65 degrees south, 145 degrees west are on the Earth's surface. Two planes P and Q take off from A at the same time and at the same speed heading towards B. Plane P flies on the parallel of latitude while plane Q flies along the longitude. Take radius of the Earth to be equal to 6370 kilometers and the value of pi to be equal to 22/7. Part A. Calculate the shortest distance between the two towns along a parallel of latitude. 3 marks. Part B. Calculate the shortest distance between the two towns along the longitude. 3 marks. And then part C. Find the position of plane P when plane Q is landing at B. 4 marks. So let's look at the points. We've been told point A is on a latitude 65 degrees south and then 35 degrees east. So this is where point A is found. And then point B is on the same latitude but then on a longitude 145 degrees west. So this is where we find point B. So the two planes are to take off from point A towards point B, but then plane P will fly along a parallel of latitude or along a small circle, so it will fly in this direction, and then plane Q will fly along a longitude. That means it will fly towards the South Pole and then to airport B. And therefore in the first question you are being told to calculate the shortest distance between the two towns along a parallel of latitude. And that means we need to find the distance here along a small circle. So the solution for part A, we are going to consider that we are finding distance in kilometers. Remember, we've been given that the radius of the Earth is equal to 6370 kilometers and the value of pi is equal to 22/7. So that guarantees us to consider distance in kilometers. Now for this case, it will be along a small circle or a circle of latitude. So distance in kilometers will be equal to theta divided by 360 degrees and then times 2 pi r cos beta. And what will be the value of theta? We are going to consider that it will be equal to 145 degrees on the western side of Greenwich plus 35 degrees on the eastern side of Greenwich. When you add the two, you get 180 degrees. So we are going to have theta to be equal to 180 degrees. So we'll have 180 degrees divided by 360, and then we multiply by 2 times 22/7 times 6370, and then cos. The value of beta is the value of, or the angle in degrees where this latitude lies from the equator, which is 65 degrees. So we're going to multiply here cos 65. And therefore, when you calculate everything with a calculator, you end up having your answer as 8,460.8 kilometers. And this is the distance in kilometers along a small circle. And then in part B, we are being told to calculate the shortest distance between the two towns along a longitude. So that distance along a longitude, it will be us moving from a point A to the South Pole and then to point B. To find the solution here, we need to consider distance along in kilometers along a great circle. So you're going to have here distance in kilometers, and then you are going to find along a great circle, which will be equal to theta divided by 360 degrees, and then we multiply by 2 pi r. And the value of theta will be equal to, we've got 65 degrees all the way to 90 degrees at the South Pole, and then from 90 back to 65 degrees. So that will be 25 plus 25, which is equal to 50 degrees. And therefore we are going to have 50 divided by 360, and then we multiply it by 2 times 22 over 7 times 6370. And by calculating here, you're going to end up getting 5,561.1 kilometers. And this is the solution. In part C of the question, you are being told to find the position of plane P when plane Q is landing at B. And remember, since the two airports are antipodal, that means the value of theta is equal to 180 degrees, it will mean that moving along a pole, for instance here, moving along the southern pole will be the shortest distance. Therefore, Q will take the shortest time to arrive at airport B. So plane P will be moving in this direction. I've shown that by an arrow. And plane Q will be moving along this other direction. In answering of this question, let's consider the following illustration. So as far as plane P is concerned, it's going to cover a distance of 8,460.8 kilometers. And this is as per our answer in part A of the question. And then plane Q is going to cover 5,561.1 kilometers. So since they are moving at the same speed and they began this journey at the same time, by the time Q is arriving at airport B from airport A here, the plane P will also be at this point having covered 5,561.1 kilometers, and it still has some kilometers to cover before it reaches point B. How many kilometers is plane P left in order to cover the distance to get to airport B? We are going to take 8,460.8 kilometers, and then we subtract 5,561.1 kilometers. And by subtraction here, we are going to get our answer as 2,899.7 kilometers. And remember, this is distance along a great circle, and this is distance along a small circle. So with this distance in mind, which will be represented here, let's find the value of theta as far as distance in kilometers along a small circle is concerned for the plane P. So you're going to consider that distance in kilometers along a small circle will be equal to theta divided by 360 degrees, and then to multiply 2 pi r cos beta. And the value of distance will be equal to 2,899.7 kilometers, to be equal to theta divided by 360 degrees times 2 times 22 over 7, and then times 6370 cos beta, which was 65 degrees. And therefore the solution here will lead us to getting 47 as our answer. So this will be equal to 2,899.7 kilometers. And then we divide both sides by 47 so that we get the value of theta. So you're going to get the value of theta to be equal to 61.7 degrees. Therefore, since the value of theta here is representing the difference in degrees between where the plane is towards airport B, to find the longitude at which the plane P is found, we are going to consider that we take 145 degrees, which is on the western side of Greenwich, and then we subtract 61.7 degrees. So by subtraction here, we are going to arrive at 83.3 degrees west. And of course, it is on a latitude 65 degrees south. And this is our solution. Question 4. A globe representing the Earth has a radius of 0.5 meters. Point A, 0 degrees 10 degrees west. B, 0 degrees 35 degrees east. P, 60 degrees north 110 degrees east. And Q, 60 degrees north 120 degrees west are marked on the globe. Part A. Find the length of the arc AB, leaving your answer in terms of pi. 3 marks. Part B. If O is the center of the latitude 60 degrees north, find the area of the minor sector or PQ. 4 marks. And then part C. If the local time at Q is 10:30 a.m. on Monday, determine the local time at P. 3 marks. Let's start by locating the points. Point A is on the equator and then on a longitude 10 degrees west. So this is where we have point A. And then point B is on the same equator but on a longitude 35 degrees east. So this is where we find point B. And then point P is on a latitude 60 degrees north and then 110 degrees east. So this is where we find point P. Point Q is on a latitude 60 degrees north and then on a longitude 125 degrees west. I captured it wrongly in the question. So this is where we find point Q. And remember, this is like a model of a globe, so we're going to consider the radius that has been given there, which is, so our radius will be equal to 0.5 meters. Part A of the question. Find the length of the arc AB, leaving your answer in terms of pi. So this is the length of the arc AB. So it is along a great circle. So we are going to consider distance, this time in meters, and it will be along a great circle, and this will be equal to theta divided by 360 degrees, and then we multiply by 2 pi r. And what is the value of theta? We are going to consider that we have 35 degrees on the eastern side of Greenwich, and then we add 10 degrees on the western side of Greenwich. So we're going to have our theta as 45 degrees. So we're going to have 45 divided by 360 degrees, and then we multiply by 2, and then we multiply by pi, and then we multiply by the radius, which is 0.5 meters. And therefore by multiplication you're going to get our answer as 0.125 pi, and this is the solution. Part B of the question. If O is the center of a latitude 60 degrees north, find the area of the minor sector or PQ. So I've picked this latitude. So this is the latitude 60 degrees north. So I'm assuming the Greenwich meridian will be passing through this point. So I can have here 0 degrees. And then you're told, we know that point P is 110 degrees east. So it will be greater than 90 degrees. It will be somewhere here. So the angle 110 is this one here. So this will take us to 110 degrees east. And then the point Q is also above 90. So this is on the eastern side of Greenwich. This is on the western side of Greenwich. The point Q is now on latitude, which is 125 degrees west in this other direction. So this is the minor sector that will be formed here. This is the minor sector that will be formed here. And in order for us to find theta as far as the minor sector is concerned, we can first of all consider the angle subtending the major arc at the center of the circle. So we're going to consider that theta will be equal to 360 degrees to subtract. So we've got 110 degrees here and 125 degrees. So this will represent the angle subtending the major arc. When you subtract from 360 degrees, we straight away get the value of theta. So this will be equal to 360 degrees to subtract the addition here, which is equal to 235 degrees. So the solution you're going to get is 125 degrees. To find the area of the minor sector, where this is O, and then you've got P and Q here, that means the area that I've shaded with the red color, we are going to consider the formula area will be equal to theta over 360 degrees to multiply the area of a circle. But then you have to remember that the radius of this circle will be equal to r cos beta, since it is the radius of a latitude or a small circle. And therefore, the radius of the globe, which was to compare with the radius of the Earth, which is 0.5 meters, when we multiply by the cos of this latitude, which is on a latitude 60 degrees north, we are going to get the value of the radius that we are going to use for this latitude. So when you multiply here, you're going to get your answer as 0.25 meters. The area of the circle here will be equal to 125 degrees, the value of theta, divided by 360, and then we multiply by 22 over 7, and then we multiply by 0.25 squared. And then the solution we are going to get is 0.0682 meters squared. And this is the area of the minor sector. Part C of the question. If the local time at Q is 10:30 a.m. on Monday, determine the local time at P. So I've captured this illustration here to help us. So the longitude of Q, which is 125 degrees west, the time at this longitude is 10:30 a.m. We want to find the time on a longitude 110 degrees east. So the value of theta we had found to be equal to 235 degrees. So therefore we need to know the difference in time here. We are going to say that if 1 degree will be equal to 4 minutes, what about 235 degrees will be equal to how many minutes? By cross multiplication here, we are going to have 235 to multiply by 4 and then divided by 1. So the solution we are going to get is 15 and 2 over 3 hours. And when you convert this time to hours and minutes, you're going to get 15 hours 40 minutes. Since this is the difference in time, and we know that the more you move towards the east, the ahead the time, we need to add these 15 hours to 10:30 a.m. This is on a Monday. So you're going to have plus 15 hours and 40 minutes. This will lead us to getting our answer as 2:10 a.m. and this will be on a Tuesday, the following day. Question 5. An aeroplane flies at an average speed of 500 knots due east from a point P, 53.4 degrees north, 40 degrees east, to another point Q. It takes 2¼ hours to reach point Q. Calculate, Roman 1, the distance in nautical miles it traveled, 1 Mach. Roman 2, the longitude of point Q to 2 decimal places, 3 Machs. So we will start. another point Q will be on the eastern side of P. Therefore, in part A, we are being told to calculate the distance in nautical miles it traveled. So we are going to consider that we've been given the speed and the time in the question. So we are going to consider the formula that distance will be equal to speed times time. And the speed has been given as 500 knots. We can also write it as 500 nautical miles per hour. And then the time has been given as 2¼ hours. So we will write here 2¼ hours. So therefore, by calculation, you're going to find that the distance you're going to get here is 1,125 nautical miles. And that is the solution for the first part. And then in the second part of the question, we are being told to find the longitude of point Q. So to find the longitude of point Q, we are going to consider the value of theta. But then now we know the distance in nautical miles between these 2 points, and we know that these 2 points are along a small circle. So therefore, to find theta, we are going to consider distance in nautical miles along a small circle, whose formula will be equal to theta times 60 cos beta. And then we have the distance to be equal to 1,125 nautical miles to be equal to theta, which is what we are looking for, and then we multiply by 60 cos, and then the value of beta is 53.4 degrees. So cos 53.4 degrees. And therefore, when you multiply 60 by cos 53.4, you end up getting 35.77. So this will be equal to 1125 nautical miles. And then when you divide both sides by 35.77 and 35.77, you end up getting the value of theta to be equal to 31.45 degrees. So theta is representing the difference in degrees between these 2 points. So we are already on 40 degrees east longitude before we consider theta. So the longitude of point Q will be equal to 40 degrees east, and then we add 31.45 degrees, and it will take us further to the east. So we end up getting our answer as 71.45 degrees east. And this is the solution.